Howdy folks. So I want to apologize for the audio quality in this video because I'm not using my regular audio recorder, of course because it's on the table in front of me. This is my Tascam DR-05. This is an excellent audio recorder, and I've been using it in my videos for I believe about a year now. And unfortunately I've had to take it apart because after I moved, I started shooting some videos, and I noticed that there was interference, of an electrical nature, on the left channel, exclusively on the left channel, which I thought was a bit strange. And as I move around my house, there are some really bad spots and some other spots, and of course, where both of my desks for filming are, they're both in relatively bad areas, so of course, go figure. And I thought this was very strange why it was only happening on one of the channels. Because you would assume if it's interference, it should be equally on both channels. So anyway, I took it apart, and well, before I took it apart, I tried to sort of shield it using pieces of sort of conductive bag from what you get like the ESD bags. I started to sort of shield it in different areas, and I could get it, I could get the interference to disappear by shielding it in certain areas, but things just didn't make sense, so I wanted to open it. And I kind of just use this as an excuse to open it because this thing is really an amazing product. I mean, Tascam is a division of TIAC, and this is professional level gear. This is their entry level product, but it is professional level. And the quality of this, even from the day I opened the box, was just amazing. Everything feels really high quality. The buttons feel really good. The interface is very straightforward. It's well designed. It's very responsive. It's got a lot of features in it. The price is good. It even comes with batteries and an SD card, like just stuff you just don't usually see. So I kind of wanted to see whether that extended to what was inside of it. And I've already looked through this. And the answer is yes. This thing is through and through amazing quality. So I would highly recommend this to anyone who's looking for an audio recorder. I'm not entirely sure what's going on with the interference. I believe it might actually be the actual electret microphone capsule itself. But I'm going to try and line this with aluminum foil and stuff. And I'm going to explain this as I take it apart. How they've done shielding, because they have done shielding in this, so that's why I'm intrigued as to why it's not working, because I've measured it and it does appear to be connected. So I'm not entirely sure what's going on there. So anyway, normally I take stuff apart on camera, but I've already taken this apart because I was working on this last night, so I'm not going to bother to put it back together. So you're going to just kind of see it in its already taken apart form. So it's an ABS plastic case with the integrated battery holder. The only real thing that I sort of don't like about this is the fact that they used a piece of plastic for the threaded insert that the tripod mount goes into. So I would have liked this to be brass, because of course through repeated inserts and removals this is going to wear out. But it does look like it is a separate piece of plastic, so it might be a different material. In which case it might not wear out as fast as the rest of the plastic, but that would be my only real sort of problem with it. It has a rubber door, which you can see. It's very simple how they've implemented that, but it works well. It's got little feet on the bottom, which is nice, and there's two more on the battery door. So if you put it down on a surface, you don't hear it, clanking as it touches the surface because it's suspended by the foam. Like they really thought of everything in this. It's very nice. So this is the unit itself. I've taken out all the screws. There's a bunch of screws that hold the back on, and then there's some screws that hold this board on. But it's actually a dual board construction. And let's see. Actually, while I've got this out, I'll mention that they've taken a lot of attention to detail in this. Like for example, the battery contacts on this side. Of course, we've just got the positive here and the negative here. And the way that they've done this in the plastic cases, there's little, you probably can't see it, but there's actually little notches in here which actually clip into these metal springs, and they hold them in place so that you can't push them in or push them down. They've taken a lot of attention to detail in this, and I really like it. So anyway, this is a two-board construction, which I was kind of surprised about. Of course, this would add a lot of extra cost, but I really do like the architecture, and I know why they did it this way. This green board on the top here, this is our digital logic board, and the black board on the bottom, which extends the full length of the unit, that is the analog board. So they've obviously separated those for shielding purposes. Of course, they want to be able to separate all the high-frequency digital stuff from all the analog stuff, because of course, you know, you have signal integrity issues if you try to do them all on one board. I mean, it's doable all on one board, but it's a lot more difficult, and this was probably a better route. Maybe not the cheaper route, but it probably tested better, so that's probably what they did here. So this is the speaker, and the speaker, of course, goes in the back panel. It just sits in here, and it's glued into place. I've taken it out just so that it's not always dangling there. But they've got foam on it so that it doesn't pop out, and they've just taped that down to the digital logic board, and this actually goes and it connects to the analog board on the bottom. So as for let's actually just take a closer look at the board here. So everything, hopefully this is in focus. There's not much interesting stuff down here. Obviously we've got some power supply stuff here, so we've got a regulator. We've got obviously our switching controller. We've got obviously our characteristic inductor. So this will be our power supply, because this thing, of course, can be powered from USB. So it's obviously a 3-volt device, or just under 3-volt device, because it's designed to operate from 2 nickel metal hydrides as well as alkalines. So 2.4 volts will be your nominal highest voltage. So it probably works down to 2 volts or so, maybe even a little bit less than that. So obviously they have to have a step-down converter for when you power it via USB. You can't charge the batteries. That would have been an interesting thing to see, but I'm not complaining about it, and I think in a professional environment no one's going to charge batteries in this thing, so I'm not surprised to not see it, but that definitely is a power supply. This chip in the center here is kind of interesting. I originally, when I first saw this, wasn't entirely sure what this was. I'm just going to move the lighting because I am having a difficult time reading these numbers. But this is a Texas Instruments LV165A, and I believe that's a 7.4 series logic part. That is actually a shift register, if I remember correctly. And I think what this is probably doing is it's probably dealing with the buttons, because all of the buttons are on the other side of this, which I should probably show you. Everything is kind of disconnected because I've taken this out so many times. But you can see on this side they've got all the buttons here. So my guess is that they're using this to basically turn all the buttons into a serial data stream. That would be my guess, just to reduce the I/O. Because of course it has to go through a connector onto the digital board, so that reduces the number of pins they need. But the buttons are very nice. You can actually, they're clicky, they're tactile buttons. And that's one thing that I noticed. They don't feel soft, they don't feel sloppy, they really feel high quality. And when you combine that with the captive button panel, it really is quite nice. So I really did like that. They've got just a regular sort of plastic window in here, and there actually is a screen protector on this. It comes with it, and I just left it on because I didn't see a reason to take it off. But it is ABS, so I mean it's not incredibly strong plastic, but it's a lot thicker than a lot of products I've seen in this kind of style. So of course on this side, nothing terribly interesting to see. We've got our LCD module, which has a backlight underneath it. We have some goop here, and we've got obviously over the connect to the bottom of the display. We've got our chip on glass, probably, which they've just filled with the silicone, which would be our row and column driver for that dot matrix LCD. We've got our 2 LEDs here, which are our record and level LEDs, and they just shine through to not actually light pipes. They're just cavities that are fully enclosed, so there's no bleed through, which is nice. And under these pads here, we've just got the connections for the 2 electret microphone capsules left and right. So as for the microphone assembly itself, there are 2 independent electret microphone capsules in this, and they're not actually twisted wiring. I actually did this myself just to try and eliminate common mode interference on that. But they are not twisted from the factory. And it's a 3-wire capsule, so these are powered, and I've tested this. The black wire is the ground, the yellow wire is a 2.2 volt supply, and the white wire is the output. So basically inside this capsule, of course you've got the microphone itself, and then there is a FET, there'd be a JFET transistor inside there, which is what that power supply is for, and that simply is used to reduce the output impedance of this capsule to probably somewhere in the order of about a kilo-ohm probably, and that just helps reduce interference over this stretch of wiring until it gets to the board, or in fact actually until it gets to the amplifier, because of course the board can have interference as well. And the way that they encapsulate it in this side I haven't taken apart, is they've got the this metallized plastic outside. So this is plastic, but it is metal, and if you actually check this with a multimeter, this is actually conductive. So this is actually the shield for the capsule, and they put the capsule in this piece of rubber. It's just a rubber grommet. And so the capsule goes inside of that, and then this goes inside of here. And we've got this piece of silver mesh, and this goes inside and it covers those holes from the inside. So it's just rolled up and sort of spring loaded in there. And we've also got a metal cover, which is incredibly hard to pick up. And this is just a metal, black metal cover which goes on the inside, so that just gets dropped in there, and that gives the end. And also there is a piece of fabric, a little piece of cloth, which goes in here on the other side of that mesh, just as a little bit of protection for the capsule itself. So this is all that is inside one of those microphones. And of course there's 2 of them, and they're mounted on this piece of black plastic here. And it's all one piece, and this is just clipped on. So there's just 4 clips which hold this on. If you push them all in, you can remove the whole microphone assembly. So I'm just going to move these out of the way. And I'm going to take off the digital board, because this is when stuff starts to get interesting. Now, the way that this is held on, there's 3 screws here that hold this on. There's 2 metal posts that poke up through for alignment. And it's really held on by what was kind of surprising to me is there's actually a board-to-board interconnect, a solid interconnect on this side over here. So this would be our all of our connection between the analog board and the digital board. There's no other connection, so everything goes through this connector. But this connector should be nothing but digital signals, because all the A to D and D to A is done on this board. So this piece of metal here, this is actually our shield, because all the analog stuff is underneath here, and this is they've gold-plated the pads underneath here, so that when this is screwed together, this is grounded, or by grounded I mean it's connected to the negative terminal of the battery. That's the ground point for everything here. And the way that they shield the actual microphones is kind of interesting. They have, it's quite clever. They've got this little metal bracket here, and what happens is there's this little notch here in the shield, and this little piece here actually attaches, this little end here actually attaches into that area. It actually clips in, and then this is sort of a spring, and it actually hooks into the two shields here, and then of course this one would hook into the other one, and then they spring together. So what this does is this sort of mechanically and electrically connects this shield with the metal shield of this, or the metal plated shield of this, and the other one on the other side, and that is what provides the grounding around the capsules, which is how this thing is supposed to prevent all interference, you know, within reason. And I've checked with my multimeter, and both of these capsules are electrically connected to this and connected to ground. They have the same DC resistance through, So, I mean, it is working. This is working correctly. However, I only get interference on the left channel, and I can't quite explain that. So next, let's look at the digital stuff. And this thing, you know, even from the moment I opened it, I could tell this was a very clean, very well done board layout and everything. And when I flipped this over, I was pleasantly surprised by the silicon I saw in this thing. Primarily, this larger chip right here. This is an Analog Devices Blackfin. And the Blackfin, this is a DSP from Analog Devices. This is not a cheap part. I would bet that this part is probably about 20 bucks, and that is a lot of money for effectively a main processor. So this, you can tell, this is not built down to a price. This is built up to a spec, and that is really nice to see. I mean, of course, TIAC probably doesn't pay the sort of one-off prices for this, but this is, when you consider this thing is about $100, even if this thing is $10 or $15, that's a decent percentage of the BOM cost of this. So, yeah, that was surprising to see. So this thing, it's an Analog Devices ADSP BF514KB CZ-4, and this thing, I think it operates up to 400 megahertz, and there's a 24 megahertz crystal here. So this I don't know what clock this exactly is running at, but it's got a decent amount of onboard memory. It's got, I think, like 100 and something K of RAM on board. So, you know, they're probably doing filtering and all sorts of other stuff in this, because they're definitely not just using this as the main processor, because there's kind of no reason to buy a DSP if you're not going to do signal processing in it. So there must be some stuff they're doing in this. So the next chip we have here is a Fidelix, I think that's how you say that, FMS 4A16LDH. So this is SRAM. This is 128 megabits of SRAM. So that's a pretty decent amount of memory for this thing, and they're obviously using this for buffering and all that other stuff, probably to do with signal processing and stuff. But that is a decent amount of memory. The next chip we've got over here is this small one right here, and this is another one that's difficult to read. This is an AU6336, and this would be our SD card controller. So this would handle all the I/O to the micro SD card, and probably expose it over some serial line like I2C or SPI or something, because this Blackfin has a decent number of those interfaces. So that's probably what they're just doing, just to make it easier rather than doing it in software on this. And this last part here is an MX25L16. I can't read that. I'll put it in the corner what that is. This is flash memory. This is a 16 megabit flash memory. So this would be where the sort of the operating system, all the firmware is on this, and that's what's loaded when this thing starts up. So underneath this can, which comes off easily because there's no screws anymore, it's just a metal plate, we have all the analog stuff, and surprisingly, there really isn't that much in here, and that's because it's all integrated into this one chip made by Cirrus Logic, sort of as you'd expect. And this chip is a 42L52CNZ, and this is basically an integrated ADC and DAC. So this does both the capture, the digitization from the analog into just raw samples. It also has the DAC, which is used for both the headphone out and the speaker, and it has a built-in headphone amplifier in it, so they don't even need a second chip for the amplification. So it's all handled in one chip, and this is of course all the passives and stuff just to support it, and all the other sort of analog-y type goodness that goes on. It's all underneath here. There is a crystal here 32.768 kilohertz. So that would be for the real-time clock that's in this, because of course when you put a battery in it, it asks you to set the clock so that way it can tag the audio, I believe, files with that. So that's what that is. We've got our hold switch here. The hold switch doesn't actually inhibit anything. I've actually tested this, and I'll explain how I did that in a later video. But the hold switch doesn't actually inhibit anything. It's just a software signal to the processor. So if you actually were to, flip the hold switch and then, press and hold the power button, the processor actually would still be running. It just wouldn't be trying to turn on. So you could actually run the battery down if you put the hold switch on and held the button. It doesn't actually stop the device from turning on. I know some devices actually, it has a real inhibit function, but this one definitely doesn't do that. So that's the inside of the Tascam or TAC DR-05. It's an excellently designed product, and I would highly recommend it. So what I'm going to do now to try and deal with the interference is, like I said, I've twisted this cable. I'm also going to wrap this cable in aluminum foil to try and create a shield, and I'm going to connect the aluminum foil to this ground pad right here. I'll just sandwich it between the pad and this leg here of the shield. And hopefully that does something, but I get the feeling that this capsule may have a problem, and if it does, I really don't. I'd have to get 2 new capsules for this because they have to be matched, and that's not easy to do because these are like I said, they've got the integrated FET, and I just did a quick search on DigiKey and I wasn't able to find anything that was even close to this. I don't even know what the specs of this are. I don't know what the output impedance is. I don't know any of that stuff. So yeah, I really don't want to go out and buy another one of these because they've gone up in price since I last checked. I actually just checked this, and they've gone up. They're now like $150 for this model, and it's a special order. So like, yeah, I'm hopefully I don't just have to put the whole thing in a Faraday cage, because that's pretty much my last resort. So if I find out what's going on with the interference, I'll tack that on the end of this video. So I'll just tack this on to the end of the video. As you can see, it's all been reassembled, and that's because I've fixed it, which is excellent. So I didn't take any video of it, but I do have some stills. What I did was I put some hot glue on the back of the electric capsule, and I did that to prevent anything from touching the 3 contact points on the back and shorting them out. Then I wrapped the entire lead from the capsule back to the circuit board in aluminum foil. So I just used some aluminum foil strips to do that. And the strip that I ended up using was an L shape. And the reason for that is because it actually connects to this screw, which goes through the board into the shield, which is all grounded and goes back to the negative terminal of the battery. And I made sure that the shield was also oversized. It was too long, such that it actually overlapped the capsule a bit and actually went around the metal can of the capsule. So what I think actually happened was I think that inside that capsule, I'm sure the capsule is bad. I think what happened was the connection inside from the ground terminal to the metal can has failed inside that capsule. So obviously the capsule isn't grounded anymore, and of course it's going to pick up everything. So what I did was, with that aluminum foil, what I basically did was, it's touching the metal can because it's inside that rubber grommet, so the grommet squeezes in on it, and that connects that all the way through to that screw, which is connected to ground. So I'm basically grounding the capsule through that aluminum foil to the shield instead of through that black ground wire to the board. That's how it's getting ground. But it doesn't really matter. It's still getting ground, and as a result, it doesn't pick up interference anymore. I mean, if I go to the absolute hottest spot in my house, and you listen really closely, you can kind of make something out, but where I film, there's no noise. So that's totally fixed. So yeah, it must be the capsule that went bad, but I'm not really complaining. I found a fix. I mean, I didn't have to use aluminum foil. I could have just soldered a wire on and ran that, but ali foil was easier. So anyway, it is fixed. So there you go. Thanks for watching.